All right, so we have seen from the previous video that the nucleus undergo beta emission when they have too many neutrons, right? So a neutron become a proton and then release one electron. But this one is reverse. When a nucleus had way too many protons, they can turn one proton. So this guy right here, so this we have proton and neutron combined, right? We'll turn one proton to become a neutron and eject one electron electron from the nucleus. Okay, some example right here. So from potassium 40 to argon 40, release one electron. What's really happening in the nucleus is one proton is used, right? So too many proton right now. So one proton is used and turn it to be a neutron. That's why the mass number doesn't change, right? So we lose one proton, gain one neutron basically. So the mass number doesn't change, but the atomic number decreases by one, right? An electron coming out. Okay. Oh, sorry. Positron coming out, not electron. This is positron. Okay. You might have heard or be familiar with PET scan, positron emission thermography. I think it's called thermography. Okay. So we will talk about this in a bit, but that's the positron emission. We talk about positron later. Okay. But I'm gonna talk about the PET scan a little bit later. But well, that's related to positron. Okay. Another one. So we have the electron capture. Okay, when in this can happen when there are too many protons. Same thing. There are two ways to release the number of protons. We can do the positron or electron capture. Okay, this one. So the nucleus will take the closest electron in the orbital. So the closest orbital is 1s. That's probably the closest one. Okay, and combine with a proton. So combine with this proton and turn it to be a neutron. And this happens when they have too many protons. Right, for example, so mercury 197 and become gold 197. All right. So if you look at the number, what's going on? So the number of protons lower by one. Right. Take that proton and electron and become a neutron. So the mass number doesn't change. Okay. All right. So we have learned five types of radiation so far. Now this time balance and identify types of radiation. Okay, so let's see what happened. By the way, pause the video, do by yourself first. Always try to do by yourself before you check your answer with me. This one, so electron capture for sure. All right, so an electron capture. So you're gonna get 26 minus 1, you're gonna get 25 here. 55 plus 0, you get 25. That's if you look at the periodic table, that's manganese. Okay, next one. Something coming out, some coming out. So that's gonna be positron emission, not positron emission, but maybe. All right, let's take a look what's going on. 7 plus 1, so we have start with 8 proton and 15 atomic number. So the number of neutrons, so 15 at the top, so that's oxygen. Okay, and it releases the positron, so we call it positron emission basically. Okay, usually happen when there are too many protons. So lower number of proton by one and add more number of neutrons. So mass number doesn't change. Next one, so Z, we don't know what that is. Let's do the math here. 221 minus 217, that's 4. Probably the alpha particle. 87 minus 85, 2 at the bottom, totally alpha particle. Okay, that's an alpha radiation. All right, down here we have neptunium 239. Become W, whatever that is. This is electron coming out. That's beta emission. Now we call beta emission, beta radiation. If you do the math, 239 at the top, 93. This has to be 94. And if you look at your periodic table, 94 is plutonium. Okay. Next one we got gamma ray coming out. So that's gamma radiation totally. And gamma radiation doesn't have mass and doesn't have charge, so it does not affect any number in here. All right, so everything the same. All right. Before we go, I would like to talk about Marie Curie real quick. So Marie Curie is a Polish chemist. So she was born in Warsaw, Poland, which is Warsaw. I think it's capital city. Okay, capital of Poland. Polish chemist and physicist. And her husband Pierre Curie, also he is a French physicist. I think they met in some kind of conference and they worked together. In 1903, both of them got Nobel Prize. Yeah, so both of them got Nobel Prize in let's say what they do. She's the first woman who won a Nobel Prize But she declined to receive that. I mean, she got it, but like declined to go to like to receive the prize in person. Declined to go to Stockholm to receive the prize in person because she and her husband was busy working. Look at that, girl power, yeah. But she was super busy, and she discovered like a lot of stuff. And two what's it element that she discovered is radium, and what's the other one? Polonium, something. And anyway, so in 1906, Pierre Curie suddenly passed away from an accident. It's like on the I was to say car, but I'm not sure they have a car at the time. They might have a car, I don't know. But yeah, he suddenly passed away, and she continually conducted the project that they did together, and she won the second Nobel Prize in 1911. Right, the discovery of radium and plutonium. Yep, the plutonium. But hold on. At the time, the radiation is not like a thing yet, and you guys know, like if you heard the word radiation or something radioactive, that's scary, right? Because it can kill people. But at that time, they didn't know what it was or how dangerous to our body that those are. Okay, so she having work is just accumulation of years with working with the radiation. She passed away from a plastic anemia, where is the condition where body cannot produce blood cells, possibly from a long-term exposure to the radiation. Okay, so radiation affects the bone marrow, right? So we have that problem. Curie family, so they got two daughters. I think two daughters. No, they got three daughters. Curie family is the most Nobel Prize decorated family. 3 Nobel Prize recipients. So 3 from this, like the mom and the dad, right? And their daughters, so there are 3 of them. Irene and her husband also received a Nobel Prize in chemistry in 1935. So Irene's right here, 1935. But she also passed away because acute leukemia from exposed to polonium and X-ray and possible exposure to the radiation. So she passed away at when she was 58 years old. Eva Denise Curie, so that's another one. So the other Curie daughter become a famous journalist and lived for 102 years because she's the only one who didn't deal anything with the radiation, and she lived the longest. She was a French and American writer, a journalist, and a pianist. So it's the only one who didn't do anything with a chemist. So and then lived the longest. And then she's the only one who did not win the Nobel Prize. So shame to the family. I'm just kidding. So 4 Nobel Prize total. This family is amazing. Okay. All right. Let's go further to radioactive decay series.